Hey there, this is Horner, and we're going to talk about this first connected objects problem. In this problem, we have two objects. We have a 5 kilogram object and we have a 10 kilogram object, and there's a force of 20 newtons that's pulling that 5 kilogram object. So let's go ahead and set up our system. Here is our 5 kilogram object, and it's connected by a string to a 10 kilogram object. And we're pulling this whole thing to the right with a force of 20 newtons. Let's go ahead and label these. We're going to label this one M2, so since it's the second one we talked about, and this one's going to be M1. And we know there's a tension between the two. That tension goes from the block getting pulled to the right, so there's one tension. Then we have another tension. And remember, the two tensions should be the same since this is Newton's third law. Let's go ahead and draw a free body diagram for each one, but we're not going to include the up and down forces. Let's do the forces just to the left and the right, because obviously we don't need to worry about up and down on this one. We have two opposing forces that are both tension. So remember, this is mass number 2, and this is mass number 1. And on mass number 1, we also have a force that is pulling it to the right. So let's set up a sum of the forces for the second block, and that we know is equal to the mass of the second block times its acceleration. And the only force that we have on this one is tension, so tension is equal to the mass of the second block times acceleration of the second block. For the first block, we're going to say the sum of the forces for the first block is equal to m1a. And we know that we typically say that this is the positive x direction. Remember, we're not worrying about the y direction for this one because this is just sitting, well, we probably could draw a table here if we wanted to. It's frictionless, so there's no friction here at all. And it is getting pulled to the right. For the force, that's positive since it's to the right. The tension is negative since it's to the left, and that's equal to m1 times a. We already said that tension is m2 times a, so we're going to say F minus, and then we're going to just substitute. So what I'll do is this m2a is going to go right in where tension is. Now we can put in m2a is equal to m1a. Let's get both of the accelerations on the same sides. To do that, we're going to say F is equal to m1a plus m2a, because all we did here was we added m2a to both sides. Let's factor out acceleration. So F is equal to a times m1 plus m2. And if we want just acceleration by itself, that would be equal to the force, and then we're going to divide both sides by m1 plus m2. Now we have an equation we can work with, so that equation is acceleration is equal to the force divided by the first mass plus the second mass. Our force was 20 newtons. We're going to divide that by the first mass, which is 5, and the second mass, which is 10. And if you go ahead and do all your math, you'll get 20 divided by 15, which is 1.3 meters per second squared. This is the hardest part, is just finding the acceleration. Once you have that acceleration, finding the tension is easy. Here's an equation that we can use for tension. It's got a single thing in it. It's just T is equal to m2 times a. Our second mass we said is 10. The acceleration is 1.3. And if you multiply those two together, you should get 13 newtons for the tension. And that's probably the easiest problem on the packet here. And we're just trying to find the acceleration first, and then we found the tension, and we used all of our equations, we get all the points, and we do really well on the AP exam. That's it. Thanks.